NASA's Voyager 1, the furthest traveled rocket, continues its extraordinary venture, communicating flawlessly across space. Important information from the farthest regions of the universe has been transmitted for nearly 50 years. This amazing spacecraft has transformed our perception of space. But recently, the space apparatus has been sending disturbing information back to Earth, putting the entire space industry in shock. Are these alarming signs the result of a malfunction in the technology or extraterrestrial activities? Join us as we learn the truth about these remarkable transmissions. Since the beginning of written records, the universe has captivated researchers, revealing secrets that lie beyond our heavenly reach. This interest led to the historic launch of Explorer 1 and, among others, Explorer 2 wonderful missions in space. These significant missions, talked about since the beginning, were launched from NASA's Kennedy Space Center. Explorer 2 launched on August 21, 1977, and 14 days later, on September 5th, the first Explorer arrived in the same year. These two probes, each weighing a significant 720 kilograms equivalent to a small vehicle, flew into outer space during a unique alignment of the outer planets. Throughout their remarkable odyssey, these brave travelers successfully navigated different speeds and directions, leading to an important event on December 15, 1977, when Explorer 1 surpassed its identical twin. As a result of differences in their paths, Explorer 1 has followed its course ever since, becoming an important resource for us with an abundance of data and revealing the secrets of space. Before we investigate Explorer 1's shocking new discovery that astonished everyone in the space industry, let's explore the extraordinary images that the rocket took during its crucial 1978 Jovian imaging mission. Around 265 million kilometers from Earth, Explorer 1 was located. From this vantage point, it conveyed a stunning number of pictures back to Earth. In January 1979, it embarked on an extraordinary 100-hour effort capturing a captivating time-lapse video showing 10 Jupiter rotations, yielding a bounty of 3,750 pictures. We were able to observe Jupiter's magnificent dance in vivid detail. In the ensuing months, Explorer 1 wandered through the system of Jovian moons, creating an impressive revelation: the existence of a small ring around Jupiter and two brand new moons, which improved our comprehension of Jupiter's fascinating sight to guarantee safe passage and prevent a potential impact with Titan, a moon of Saturn. Corrective maneuvers were executed. Explorer 1 carried on with its celestial journey around Saturn, revealing 4 additional moons: Enceladus, Tethys, Rhea, and Dione. At the conclusion of the Saturn mission, researchers decided to conclude the Planetary Explorer mission, pushing Explorer 1 and Explorer 2 simultaneously beyond the boundaries of our group of planets, gliding through space at an incredible annual rate of 3.25 million kilometers. In January 1990, a new chapter began during the Explorer interstellar mission. During this stage, Explorer 1 provided a few iconic images of history, immortalizing the majority of the planets and the Sun. One individual from each planet played a significant part in expanding the missions, which went beyond their initial goals. Dr. Vosel Sands, a prominent astronomer and a component of the Explorer missions team, fervently supported capturing a final collection of images as a goodbye gift to humanity. Against all odds, his unwavering determination bore fruit on February 14, 1990, when Explorer 1, positioned 6 billion kilometers from the Sun, embarked on a well-known visual excursion, a planet group photo. These stunning images, totaling 60, added to the shuttle's remarkable collection of 670 photographs. Voyager 2 accomplished a remarkable feat by recording wind speeds exceeding 13,100 meters per second, making it the fastest wind ever documented in our planetary group. As the rocket drew closer to 280 million kilometers from Neptune's rich blue methane atmosphere, it gave us amazing insights into this faraway celestial body. Notably, Neptune's largest moon, Triton, was revealed to be one of the coldest residents within our planetary group. With rapidly falling surface temperatures to a frigid -391 degrees Fahrenheit, Triton's features, such as its nitrogen gas-spewing ice volcanoes that pushed icy particles 5 miles into its hazy atmosphere, also captivated our imagination. These extraordinary discoveries expanded our comprehension of the extensive variety and depth of celestial objects residing in the farthest reaches of our local planetary group. The Explorer Group's rocket has recently made one of its most frightening discoveries. But first, let's find out what it has achieved in the last 45 years. The accomplishments of the Explorer twin tests have produced nothing less than extraordinary. 4 decades ago, their initial observations of Jupiter's and Saturn's moons left scientists in awe and shattered previous assumptions about these remote worlds. These moons, once believed to be dormant and heavily scarred like our own moon, proved to be overflowing with geological activity. Explorer 2 specifically achieved several exceptional feats. It made history on its journey in 1986 when it became the first space shuttle to fly by Uranus. Just 3 years later, it achieved another remarkable feat with a flyby of Neptune. All the way up to the present, it is still the only rocket that has traveled in the same direction as the Explorer. NASA continued the journey of the rockets, implementing various measures to extend their duration of operation. In recent years, heaters and unnecessary parts have been turned off to save energy, ensuring that these courageous explorers can continue their mission well into the future. Their mission is expected to end in 10 years, with 2030 set as the target year for scientists and engineers who have been a part of this impressive undertaking from the very beginning. The culmination of the Explorer missions is both a moment of pride and a tinge of melancholy. Their steadfast dedication and efforts have far exceeded the wealth of their initial expectations. The data that the explorers returned has provided valuable insights, fueled numerous discoveries in science, and ignited the imagination of countless researchers and space enthusiasts. Neither Explorer 1 nor Explorer 2 were ordinary spacecraft. They were meticulously constructed to be stable platforms with a rotation rate over 15 times slower than a clock's hour hand. This design choice reduced visual haze as the spacecraft moved, capturing data and images while traversing the vast expanse of space. Even prior to their interactions with the outer planets, their impressive imaging abilities began to astonish scientists and the general public. As the spacecraft started sending images of Jupiter prior to reaching the gas giant, early pictures of the swirling clouds and the famous Great Red Spot delighted audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly took the spotlight. Io, somewhat larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments identified unusual signals from Io, which were confirmed by the distinctive images they captured. Towering volcanic plumes and a surface scarred by volcanic eruptions were revealed. One of Io's most prominent volcanoes erupted violently, 10 times greater than Mount St. Helens, covering an area almost the size of France, while the cameras on the spacecraft were eventually shut down to save power and recollection prior to their journey into interstellar space. It is interesting to note that the pictures they took did not include Mars and Mercury for various reasons. In addition to Explorer 1 and Explorer 2, NASA has launched other prominent spacecraft, such as Voyager 10, 11, and New Horizons. Explorer 1 passed by Voyager 10 on February 17, 1999, marking the occasion when Voyager 10 became the most distant spacecraft. Explorer 1 continued its individual journey. Another 14 years passed before it finally entered the interstellar environment on August 25, 2012. Despite the absence of any other space probes in sight to witness, NASA didn't publicly announce this remarkable achievement until 2013. One method stood out as exceptionally effective in ensuring the Explorer mission's success: gravity assist maneuvers. These maneuvers played a crucial role in accelerating Explorer 1 and Explorer 2 on their bold mission to investigate the farthest reaches of our solar system. These faraway destinations and collecting useful data, the spacecraft needed more than just propulsion. They required their own systems of propulsion, a boost, and the assistance of gravity. Just imagine the two fearless rockets, Voyager 1 and Voyager 2, embarking on their grand tour through the local group of planets. Rather than relying purely on the back of their motors, they participated with others in a celestial dance. Of the planet's major players, these planets joined together to perform an incredible dance, leveraging the vast gravity of these giants pulled to slingshot as they proceeded. This method enabled them to preserve priceless fuel, get the necessary speed, and visit various destinations. Delving into the basics of gravity also helps. What is known as a gravitational slingshot. Observe the strategy behind this action. It is to move some of the energy from a planet to the spacecraft as it nears. Consider Explorer 1 approaching Jupiter, a massive gas giant with a matching gravitational pull. With meticulous precision, Explorer 1 struck Jupiter at the ideal speed and angle. Jupiter's gravity pushed the spacecraft around, bringing it up to a higher speed and providing it with a significant boost. Performing a gravity assist maneuver requires a high level of precision. If Explorer 1 had approached Jupiter at the improper speed or angle, the slingshot might have resulted in a disastrous deviation from the course it was intended to take. The required level of accuracy is daunting. However, the creative thoughts that go into these missions successfully executed these multiple instances of gravity assistance, putting the Explorer spacecraft in motion on an awe-inspiring tour of the local group. Explorer 2, for instance, utilized gravity assists from Jupiter and Saturn to reach Neptune and Uranus. These important celestial maneuvers played a crucial role in making the grand tour possible. The Explorer missions owe much to the success of these gravity assist maneuvers. Explorer 1 kept reaching interstellar space, with Explorer 2 quickly doing the same, all thanks to the precision of these maneuvers. The idea behind gravity assist is simple, but the execution is extremely complex. Explorer 2's grand tours required a level of precision. When any of these slingshots could have resulted in a mission failure, the dedicated people behind these missions were tenacious and determined in their pursuit of knowledge. In contrast, gravity assists contributed significantly to exploring the cosmos. Yet another essential component made certain that the Deep Space Network (DSN) exploration missions were successful. DSN is frequently regarded as the interstellar phone line that allowed us to stay in touch with brave explorations by the explorers. DSN, however, ventures into the vast unknown. Less flashy than a spacecraft, it is equally essential. The Deep Space Network is a network of enormous radio antennas carefully spaced out around the world, including locations in California, Australia, and Spain. These enormous dishes, ranging from 26 to an incredible 70 meters in diameter, serve as significant amplifiers easing the communication process with spacecraft orbiting other planets. The Explorer probes, with cameras, sensors, and instruments, served as our eyes and ears in the vastness of space. To make sense of the information they sent, and to supply them with new directions, an effective communication system was crucial. And this is where the DSN was implemented. Imagine Voyager 1, on its way to the outer reaches of the solar system, sending a message back to Earth as a faint signal traveling at the speed of light. As it moves through space, the signal weakens by a factor of billions by the time it reaches Earth. However, colossal radio antennas of the DSN are set to capture that whisper. They lock onto Voyager's weak signal, working on it and converting it into data that can be analyzed by scientists. The DSN not only receives signals, but also sends instructions to the Explorer missions. Explorations call for scientists and engineers to adjust trajectories, modify or reorient the spacecrafts. Instruments that are used to send commands, the DSN distributes them into space to reach Voyager and guide it. It operates as a dialogue between the closest point to Earth and objects made by humans in the universe. One of the DSN's remarkable features is its continuous operation. It operates 24/7, listening for those distant signals. It's like keeping a watchful eye on the universe, ensuring that we stay connected to our space probes even when they are billions of miles away. The Explorer missions stand as a testament to the power of innovation and collaboration. As the spacecraft set out on their grand trips, the DSN made sure they were never truly alone. It bridged the gap between the unknown and our planet, allowing us to investigate other planets and venture into interstellar space. Did one of the explorers experience a breakdown, or were extraterrestrials involved? Throughout their remarkable 45-year journey in space, the Voyager 1 spacecraft has remained healthy and diligently carried out its mission. But experts in recent times have observed a few anomalies in performance that have attracted attention and curiosity. Explorer 1 is currently transmitting strange signals to Earth, creating the impression that it is uncertain about its exact location coordinates. What makes this discovery even more perplexing is that the information gathered from Explorer 1 is impossible to comprehend, causing scientists at NASA to wonder. Upon examination, scientists found that the responsible system for the erroneous data was the Attitude, Articulation, and Control System, AACS. Measuring is performed by equipment logging and making adjustments to the spacecraft's antenna in space, directed at Earth, making it able to send data back home. The malfunction had happened when the software suddenly changed to sending data from its telemetry through a faulty embedded computer that had been idle for a long time. NASA engineers were able to fix this anomaly by telling the spaceship to continue sending data through the proper channel. As a result, the computer freed up data NASA is once again receiving from Explorer 1. Despite this, the question remains, why did the spacecraft switch to the malfunctioning computer in the first place?
While NASA scientists have proposed
The hypothesis that an erroneous instruction from another onboard computer caused the strange behavior. They have yet to determine the precise cause. At the heart of this mystery is Susan Dodd, manager of the Interstellar Project. The mission stated their intention to perform a comprehensive memory readout of the spacecraft and thoroughly examine its systems. This in-depth investigation aims to investigate the problem that led to the telemetry issue. It deserves special attention that, despite the inconsistent data transmission, the spacecraft itself seems to be working as intended. None of the systematic fault protection for spacecraft have been triggered. As such, Explorer 1 has not been forced into safe mode, and its signal is still strong. A factor contributing to this inconsistency is the harsh environment of space. Radiation from the cosmos and extreme changes in temperature can cause challenges to the operation of a spacecraft like Explorer 1. Cosmic radiation has a lot of energy particles, originating from distant stars and galaxies. These particles can penetrate the structures of spacecraft, resulting in electrical disturbances, signal distortions, memory errors, and data corruption. Additionally, temperatures in the vastness of space can drop to bone-chilling lows or soar to scorching highs, exerting a great deal of stress on the components of spacecraft. Despite the rigorous testing and meticulous engineering used in the design, Explorer 1 is able to resist these conditions, but the harsh space environment can still take a toll over time. Another intriguing possibility that has captured some people's imaginations is the idea of extraterrestrial interference. Could the anomalous behavior of the Explorer be attributed to the actions of intelligent entities from other solar systems? Despite the fact that this idea may seem more like science fiction than reality, it is not completely out of the realm of possibility. The vastness of space and the numerous exoplanets it possesses permits speculation regarding civilizations considerably more advanced than our own. But before leaping to conclusions of extraterrestrial intervention, scientists are focusing their attention on every aspect of Explorer 1's irregular behavior. Whether the spacecraft's anomaly is due to a technical glitch, cosmic radiation, or something else, one thing remains certain: the unsolved mysteries of space will keep captivating and inspiring us, driving our unrelenting search for understanding and knowledge of the cosmos.